Okay, today we're going to be talking about how to simplify radicals. So first we need to discuss what a radical is. It's a symbol that looks like this. It's a little check mark with a roof on the top. This is the most common way you'll see the radical. This represents a square root when there's not anything to tell you otherwise. However, sometimes we can have cubed roots, we can take fourth roots, fifth roots, etc. So whatever root it is, there can be a little number inside that little check mark there. A little baby number right inside the check mark. Don't write it in front because that'll make it look like multiplication. So it has to be right inside that little check mark. This number is called the index, or what root it is. If there's no index specified, then it's, like we said, it's automatically the squared. Okay, so that's the index. This little, the check mark, the square root symbol, is called the radical symbol. And then anything that's inside that square root symbol or underneath the square root is called the radicand. So whatever you're taking the root of. And then the whole thing together is the radical. Okay, so you don't really need to know all of these individual names. The main thing you have to understand is that whenever there's a little number right above that check mark part of the square root symbol, or of the radical symbol, that tells you what root you're taking. And if there isn't a root specified, it's implied to be squared. Gentlemen, please. Okay, so we're going to be focusing on square roots today. So again, square roots will either just look like with just the radical symbol with no index indicated, or sometimes there will be the little 2 above that check mark to let you know that it's the square root. So a perfect square is the product. If you remember, a product means the answer to a multiplication problem. So perfect square is the product of a number multiplied by itself. So the perfect square is the answer to that multiplication problem. When you're multiplying a number by itself, that also means you're squaring that number. Some common examples, or the most popular examples of perfect square. So again, if you just start going down the line of the natural numbers that we know and just start squaring them, you'll get perfect squares. So what's 1 squared? 1. So 1 is a perfect square. 2 squared is 4. 4 is a perfect square. 3 squared is 9. 9 is a perfect square, and so on. You just keep squaring the numbers. That will get you the perfect squares. So again, these numbers down here, the answers to those multiplication problems, those are the perfect squares. Okay, and again, there are more. There's infinite amounts of perfect squares as long as you just keep. You can do 11 squared, 12 squared, etc. You can keep going. These are just the first 10. Okay, so using these numbers, using these perfect squares, this is how we're going to simplify square roots. So we are also going to use the product rule, which says if we have two numbers that are being multiplied underneath a square root, so like a times b, that multiplication is happening underneath the square root. That's the same as splitting up that multiplication with each number in its own square root. So the square root of a times b is the same as saying the square root of a times the square root of b. So you can split it up like that. You can also go the other way. If you have square root of a times square root of b, you can rewrite it as that multiplication happening under one square root as the square root of a times b. Okay, so that's the main rule we're going to use to simplify. Right below that, it says also it will be helpful to find, and this is where we're going to use our perfect squares, to find the perfect square, or the largest perfect square that the radical, or that number under the square root, is divisible by. Because since square roots, those nice perfect numbers, those are square roots of the perfect squares are the ones that can be evaluated, that can be a nice normal number and not an ugly decimal, which will help us in simplifying. So for example, if we had like the square root of 16, that's the same as saying the square root of 4 times 4. Would you agree? 4 times 4 is 16. Nothing groundbreaking there. Then we can use our product rule to break it up. And the square root of 4 is equal to 2. And we have 2 of them. 2 times 2 is equal to 4. You don't have to write all these steps. I'm just showing you why it works when you do it. So the square root of 16 with that square root symbol is equal to 4 with no square root. So that is helpful in simplifying. The goal is to have the smallest number we can in that square root and then evaluate anything that we can. Okay, so let's do an example together. So example 1a. Whenever we have a number like this 2 right out in front of something that's grouping, again, a square root is another way to group things together, like parentheses and absolute values. What is happening right here in between the 2 and that square root? What operation? If there's nothing written, what is it implying that we're doing? If it was this, if it was like this, 2 and then a 75 in parentheses, what would you do? Multiply. It's the same thing. So this is implied multiplication in there. So really this is saying 2 times the square root of 75. So the 2 is fine. The 2 does not have a square root attached to it, so we're going to not worry about the 2 right now. I am going to just take it and draw an arrow down so that once we're done simplifying the square root of 75, I don't forget that that 2 is there. But now looking at the square root of 75, I want to try to simplify that. So to do that, I want to look at my list of perfect squares here. So the 1, 4, 9, 16, all of those, and determine if there are any of these perfect squares that can go into 75. 1 isn't going to help us very much, so I would start at 4. So if you just start doing 75 divided by these perfect squares and see what one gives you a nice number. So in your calculator, you can do 75 divided by 4. See what that gives you. If it's a nice number, cool. If it's an ugly decimal, move on. So 75 divided by 4, is that a decimal or a nice number? Decimal. All right, move on. 75 divided by 9, what does that give you? Decimal. 75 divided by 16. Decimal. 75 divided by 25. There we go. That's a nice number. So we can now, when we have our square root of 75, we can rewrite this as the square root of, you said 75 divided by 25 was 3. So we can rewrite 75 as 25 times 3. Right, that's the same thing as 75. We're just writing that number as a multiplication problem. And now we can use the product rule. So when we have that multiplication happening underneath the square root, this is where we can split it up. So instead of having the square root of 25 times 3, we can have two square roots. The square root of 25 times the square root of 3. This is using the product rule. Okay, now we look at each square root individually. So we can always test them in our calculator. To get the square root symbol in your calculator, if you hit the second button, and then the key below it that has an x squared on it, you should see the little square root symbol above it in blue. If you hit second x squared on your calculator, second x squared, then the square root symbol should show up. And then you can type in 25, and then hit enter. And what do you get? 5. Because if we look up here with our perfect squares, when we did 5 times 5, that gave us 25. So the square root of 25 is 5. The square root is now gone. You have evaluated the square root. So the square root of 25 is just 5. No square root. Okay, square root of 25 equals 5. No square root. Yep. And then this is now 5 times square root of 3. We need to double check though. Try square root of 3 in your calculator. You always need to double check if you think you're done. It's a decimal?
Yes.
Okay. Now we need to check, can any perfect squares go into 3? Can you do 3 divided by any of these and get a nice number? Or will you get decimals for all of them? What's 3 divided by 4? It's point something. 3 divided by 9.
You're going to get decimals for all.
That's what I'm asking. Okay, yeah. You're going to get decimals for everything. So that means that is simplified completely. You can't do anything else to it. So, but now we can't forget about this 2 that we had out in front. And remember we said that 2 is being multiplied. So really, we're going to have 2 times 5 times the square root of 3. Yeah, both the 2 and the 5 are outside of the square root, so we can multiply those together. We'll have 10 square root of 3, or you can write that multiplication symbol in there if you want. But that would be your final answer. And you can double check. You can see if you did it correctly. In your calculator, type in 10, and then do your second x squared, get your square root of 3, hit enter. I know it'll give you an ugly decimal, but that's okay. Yeah, and then if you type in the original one, 2, and then your second x squared, square root of 75, you should get the same ugly decimal. Okay, so that's a way you can always check your answers to see if you did it correctly. If you don't get the same decimal, then something happened. Okay, let's try another one together. Letter B. This time there's nothing being multiplied out in front, so we don't have to worry about that. We just have to focus on simplifying. So we have our square root of 500. So we want to find one of these perfect squares that can go into 500. 10 isn't a perfect square, but 100 is a perfect square. 25 would work too. You would just have to do some extra simplifying after. So that's fine if you want to go through and use 25. You just have to make sure you double check to see if you're simplified. But 100 is a perfect square that also goes into 500. 100 times what gives us 500? 5. So we can split this up as the square root of 100 times 5. We're just rewriting that 500. It's the same thing. Then we use our product rule to split up that square root. So we'll have the square root of 100 times the square root of 5. And now we can just use our calculator. Again, to get the square root symbol, I'm going to write this in the notes here. You have the second key, and then x squared. And that gives you the square root symbol in your calculator. So try both of these. Square root of 100, what does that give you? 10. With a square root? Would I do this? No. Once you evaluate that square root, once you do square root of something and your calculator gives you a nice number, square root symbol's gone. Square root of 5, do we know what that is? No, it's an ugly decimal. Can any of our perfect squares go into 5? No, so then we're done. So 10 square root 5. Again, you can have 10 times square root 5 if you want to write the multiplication symbol. Just a personal preference if you want to write that or not.
That's the answer?
That's the answer.
Why was this so much harder last year?
Because I didn't teach it.
Ooh.
I don't know.
So true.
Probably because you've seen it before, so it helps.
Thanks.
All right, do you guys have any questions?
She couldn't teach it all.
Can you guys try C and D? So notice C has this 3 on the outside that you have to make sure you multiply at the very end. Try C and D. I'll be around if you have any questions. All right, so letter C. You should have split it up into the square root of 4 times the square root of 5. Are we all good that far?
Yes.
Yes? Okay. Then you just do one square root at a time. So if you did square root of 5 in your calculator, it should have given you an ugly decimal. That means it has to stay. You have to leave it as square root of 5. You're stuck with it. You can't do anything. Square root of 4, if you did that in your calculator, it should have given you 2, a nice number of 2 with no square root around it. So that 2 gets to come out. You'll have that 3, that was out in the very front. 3 times 2, square root of 5, should give you 6. Square root of 5 as your final answer. Smiley face is optional. What? Do you have a question? Oh, okay. Any questions on C? Okay. Letter D, were there any perfect squares that could go into 17? Was square root of 17 a nice number when you did it in your calculator? What? You did square root of 17 in your calculator and you got 1?
No, he's saying that 1 could go into it.
Oh, 1. But how do you get 1 times what is 17?
17.
So it's not going to help you at all. So when we're simplifying, using 1 is kind of counterproductive there. So that means since no perfect squares can go into 17 and the square root of 17 itself is not a nice number, that is your final answer. That's already as simplified as you can go. All right? You guys have any questions?
No.
Okay.